Good afternoon, everybody. This is Loretta Zita. I'm the Director of Marketing and Communications at HRAI, and I want to thank everybody for attending this webinar. Before we get started, I want to go over a few housekeeping issues. Everyone's on mute to reduce some of the background noise. The session will be recorded and available after the session. Feel free to add any questions in the Q&A section located at the bottom of your screen. Throughout the presentation. We will get to these questions at the end of the session. And if any of you would like to ask your questions verbally, please note that in your question. And if you have any technical difficulties, if you could use the chat section to let me know, and I'll try to help you as soon as possible. So with that, let's get started with today's presentation. Today, we're joined by Rusty Tharp, Senior Director of Regulatory Affairs with Goodman Manufacturing Company. He'll be taking us through next generation refrigerants for, Anirudh, you might want to just mute yourself. Thank you so much. He'll be taking us through the next generation refrigerants for residential heat pump and air conditioning. He has 35 years of HVAC experience, having worked for major manufacturers of residential and commercial heating and cooling equipment after receiving his BSME from Rose-Hulman Institute of Technology. And with that, I'm going to kick this over to Rusty, and you can take it away.
Thank you very much, and happy Thursday to everyone. We'll go ahead and get started. And welcome to the discussion on residential AC and heat pump next-gen refrigerants. Some of the slides that are in this deck are from the HRI Safe Refrigerant Transition Task Force. There are terms of use. It is copyrighted material, so please make sure that you look at the copyright requirements. And please note that audio, photos, and video recordings of the content are prohibited for the HRI. Have 7 different sections I'm going to go through, and the first 2 will go very quickly over. Hopefully most are aware of these, but the first thing, I just want to make sure everybody's on the same page when it comes to types of refrigerants. So in the ASHRAE 34 standard, it is a designation for, as the title indicates, it's the designation and safety classification of refrigerants. And refrigerants are classified in 2 ways. Per ASHRAE 34. One of them is based on toxicity, where A is a lower toxicity rating, and B is for refrigerants that have higher toxicity. That's also rated, the number indicates the flammability. 1 indicates that there's no flame propagation at standard test conditions. 2L indicates that there is flame propagation, but it has a very low heat of combustion as well as a low burning velocity. And then a 2 flammability indicates that it is fairly flammable, gives off a fair amount of heat of combustion, and has certain LFL properties. And then a 3 indicates that it's very flammable. And as you look over on the right side of the page, you can see some examples. From a flammability perspective, propane is a A3. And I think we're all familiar with propane. R152A is considered an A2. 152A is used quite often in propellants and aerosol cans. From a A2L or B2L perspective, R32 is an A2L. I would assume that a lot of folks have heard of those. And then I'm sure everyone has also heard of ammonia, and ammonia is rated a B2L. It is toxic. I know everybody knows what the smell of ammonia is like, or maybe you know what the smell of ammonia is like. And then the current refrigerant we use today is 410A, and that is considered an A1 by classification. So all the classifications are set by ASHRAE 34 here in North America. Just one quick slide that shows some of the refrigerants that have been historically used. I'm sure everyone's aware that R22, and again, I'm looking at DX Human Comfort, primarily residential systems. as the main areas here. R22 is an HCFC that is banned from use presently due to ozone depletion potential, or ODP. There were some alternates that were used in an interim period, such as 407C. The current refrigerant we use for almost all systems is R410A. And then if you look at the chillers, which are grayed out, so this presentation was for some other applications, but if you look at chillers and refrigeration, a lot of the more common refrigerants are listed there. And the one thing to note is that all of these refrigerants are A1s. And we'll explain in a minute why that's going to change. So the next step of the presentation is to talk a little bit about the reason for some of the changes in the refrigerants. This has been, I know there's been other presentations that have given similar to HRI folks who have given similar information. But basically the point of this slide is that if we continue down the path we're on, that the emissions of HFCs into the atmosphere are going to increase dramatically. So that's what the chart on the left shows. We've gotten rid of the ozone depletion refrigerants, but now the HFCs are taking their place. So if we don't do something, then what is on the right is going to happen, and that's the surface temperature change due to the refrigerants that are in the atmosphere. So because of the emissions of refrigerants, then we're expecting global warming to occur. So the intent is then to take some actions to mitigate the potential global warming. The Kigali Amendment, I believe it was 2016 that it was signed, basically defined some steps, a step down, a phase down, not a phase out of these HFC refrigerants. So if you remember all the the ozone depletion chemicals like R12 and R22, R11, those are basically being phased out for usage altogether. For these HFCs, it's a phase down. There'll still be some use permitted at the end, but it will be a limited use. So as you note, the red and orange bars lines are what is for non-A5 countries, more developed countries, and underdeveloped countries have to follow the blue and yellow lines. Again, this was an agreement back in 2016 that is not binding until a country adopts the steps, which then takes us to the point that Canada and Mexico have already ratified the Kigali Amendment. And in the United States, there are, while the US Senate has not been given yet the Kigali Amendment to sign on as a treaty, there are multiple states that are taking action to implement some of the step downs of the Kigali Amendment. One of the most notable is California, with the California Air Resources Board, who is proposing a requirement for some limited systems starting in January 2023, others in 2024. The DX systems, the typical residential systems, like the subject of this would be January 2025, and then VRF systems in January 2026. So because of the global warming and the Kigali Amendment, the changes are coming to the refrigerants so that we have refrigerants that have less impact on the atmosphere. So what I'd like to do next is take a look at some of the replacement refrigerants that we expect to see. And as manufacturers look at the options for refrigerants, just like pretty much everything else in life, excuse me, I need a drink here. Like everything else in life, there's pros and cons in various areas, right? So one of the ways that many people look at some refrigerant options is, they referred to as a spider chart. And the further out the number, the better a given refrigerant is. So if you look at 410A, the pink on the left, it's a relatively good refrigerant, except it has its biggest problem is it has a significant environmental impact. If you look at R32, it has very good performance all the way around, except because it's an A2L, it's not the perfect solution from a safety perspective. If you look at R466A, again, it's not perfect from a safety perspective because it has a lower toxicity limit than some of the other options. Economic value for both actually 466A and 454B, those are patented blends. Therefore, the economic aspect of it is a little more challenging. For 466A, also the environmental, it has a higher GWP than some of the options, as well as it requires more refrigerant than some of the other options. And so as you look at, these are the primary choices that are publicly being considered by most of the companies. Some companies today have made announcements. Goodman and Daikin have announced that we will be using R32. So most of my presentation will be focusing on the aspects of R32. So as we look at what R32 is, one thing to note that 410A is actually a blend of a binary blend of R32 and 125. It is a HFC refrigerant. It's mildly flammable, so it is classified as the A2L, but it does have a 0 ozone depletion potential, and it does have relatively higher system efficiency. So depending upon the studies that you look at, anywhere from mid to high single-digit improvement in efficiency for the cycle itself. There are concerns such as that R32 has a slightly higher discharge temperature, but those are things that can be taken account of in the design of the equipment so that they're properly applied, when properly applied and charged, that the system will not have any negative impacts. All right, so moving on, again, just looking at a little more of the advantages that we feel R32 has, even over R410A itself. It does have the lower GWP. So if you're looking at the AR4 values, R410A has R22 had a value of roughly 1800. R410A actually went up to 2088, and R32 is down at 675. But because it has a better thermal conductivity, better viscosity, lower density, which the lower density means you need less of it, depending upon the study that you use, for equivalent system holding everything else constant, R32 can use anywhere from 20 to 30% or maybe even more less refrigerant than 410A. So you get a double benefit, more bang for the buck by using R32, because we get a decrease in the GWP value and you use less of the refrigerant. So the weighted value is significantly better. And per our estimates, it's roughly 25% of the net emissions when you compare it to 410A. One of the other benefits of choosing R32 is that it is a trusted worldwide. Going back historically, you can see that R32 was first adopted in Japan in 2012. It's been used it started being used in Europe a year later, Australia a year after that. There are some limited products in North America, PTAX and window air conditioners in 2016. Some developing countries even before then. And the point at this time, there's well over 140 million units. A lot of these are the ductless style that are quite often installed in Canada. There's over 140 million of those that are installed in 70 different countries, and those are all manufactured by 40 different OEMs. So there's a lot of product out there. So it has a well-proven history of a full decade of use at this point. The next phase of the presentation goes into safety standard and some application requirements. One of the things we need to remember as you're going to a A2L system is, just like any fuel, there are three things necessary for an ignition to occur. First is you have to have the presence of oxygen. So if there's no oxygen present, you're not going to be able to ignite. You also have to have a occurrence of a leak, or a leak that provides enough of the refrigerant to get above the LFL, or the lower flammability limit. And then there also has to be the presence of a ignition source. So without all three of those happening at the exact same time, then there would not be an ignition. So with that in mind, to go into discuss the ignition perspective, when with R32 and other A2Ls, it's much more difficult to ignite than hydrocarbons. So if you look at this graphic, it shows that the spark energy required to ignite R32 is significantly higher than other fluids such as hydrogen, isobutane, propane, et cetera. And from the last bullet, there was a study done by AHRI, which I'll mention again in a minute, HRI 8017, that looked at many common household items, toasters, electric heaters, drills, blenders, et cetera, and even looked at things like lit cigarettes, and none of those would ignite an A2L. So it's significantly harder to ignite A2Ls. And so having that knowledge, the safety standards basically have a strategy of trying to prevent ignition and prevent combustion. And the way that is done is controlling and isolating any ignition sources in the equipment itself, and specifying in the installation instructions what can be around the equipment. There's a lot of construction requirements that go into the air conditioning units as to help prevent leaks. Where there's also refrigerant charge quantity limits that will be specified either for a single package unit, or a factory sealed system, or a split system. And that goes in line with minimum areas that have to be checked in order to make sure that it's a safe application, so that in the event that all the refrigerant does leak out, you don't get to a point where you might have a combustible mix. There's a lot of labeling and a lot of information in the installation instructions and service manuals that are specified for contractors and consumers to follow. And one of the last safety items is that in the event, some of the systems will have active mitigation, so that in the event a refrigerant leak is detected, that blowers will turn on and circulate air to help make sure that there are no zones that have a flammable mixture. So I mentioned that the safety standards and codes are being developed based upon some research. This is only a partial listing of research that was done by industry as an aggregate. This does not include any research that individual manufacturers are doing or have done. And as you can see, there's a very extensive list of research projects that have been concluded at this point. I'll just point out that, like AHRI 9015, that is an assessment of the requirements that are in the 3rd edition of the product safety standard, as well as for the North American, 3rd edition of the North American safety standard, and 6th edition of the international standard. And that had some really good information in it that helped define criteria that will be going into future revisions of codes and standards. So again, the takeaway from here is that there's a lot of research being done to help make sure that these are safe. And then as the point for this slide is that as these research projects and the standards are being completed, and model codes are being adopted, revised to address A2L specifically, it's a continual process. ASHRAE 34 actually created the A2L category in 2007-2008 timeframe. EPA has introduced its first SNAP approval back in 2016. that may have been 2015. I may have that year wrong, but for Rule 15, allowing window air conditioners and packaged terminal air conditioners and heat pumps to use these A2L refrigerants. There's been a lot of work in safety standards. I know B52, the 2018 edition, was modified to address A2Ls to some extent. B52 is presently being modified also. I'm a guest actually on that committee and participating. There's the CSA 4th edition of the product safety standard is under development today. I and others in the industry are, as well as all stakeholders, are participating in those codes and standards. And those are being modified to more properly address these A2L systems to allow for even the systems, especially with the bigger charges that may occur, especially in the commercial arena. But the point is, there's always revisions going on. So for the CSA, if you look at the C22.2 standard, it's gone on. There's been multiple revisions. I think it's on before going to the 2-40 standard. The 1995 standard was on its 5th edition. So there's continual revisions to the codes and standards. Those are continuing going on today. As I mentioned, so EPA, before, at least in the United States, before manufacturers can use certain refrigerants, they have to be approved by the United States Environmental Protection Agency. So EPA did issue SNAP Rule 23 in June of, actually, I think they released it in May of this year, and it was effective in June of this year. That allows these A2L refrigerants for air conditioners in the United States. One of the things that they've done is they've indicated that that has to be red marking on tubing wherever the servicing is going to be done, and where there's going to be potential puncturing of the lines, there can be red marking. So, and there's also a whole bunch of warning labels. I think there's 6 or 7 different warning labels that are specific to A2L systems, and those are going to have very large letters. Most lettering is about half the size. EPA has requiring, so the product safety standard only requires 3.2 millimeters. EPA is requiring 6.4 millimeters. So when these units come to you, you will see several differences, especially if you're looking for things of this nature. That will help you identify whether the unit has a A2L refrigerant or not. But as you go to try to make these systems safe, just 4 key takeaways that I would like you to walk away with is that as you're installing these systems in the field, one of the things that will need to be done is to verify that the minimum area is met. In order to do that, you have to know what the refrigerant charge quantity is. And that charge quantity for split systems will be the factory and the field charge. You need to make sure that you review labels and literature to make sure that you're familiar with what the manufacturer is specifying, because there will be some additional requirements for installation and service that will be in the literature and noted on labels. And then also, just as you should be doing today, that you use care during installation service, right? So air conditioning equipment today has high pressure, you've got electricity. So there needs to be care taken as you're installing and servicing AC and heat pump today. And that same, a little bit more care is proven with A2Ls. The next step in the presentation is talking a little bit about transportation and storage. One thing to remember is that most refrigerants are heavier than air. So as you are in the event there's a leak and there's no air movement, that the refrigerant will typically fall to the floor, and there might be higher concentration at lower levels. Therefore, one of the things that's very good is to keep air circulation going around where you're servicing the equipment. When you get to transportation, either the cylinders or units in the van, just remember there's one of the things to obviously remember, there's always local, provincial, state, and federal regulations. So those always take precedence. But there are some restrictions that exist today So we expect that for R32, the transportation of cylinders is not going to be significantly different. And that if you think that there is a potential leak, then you'll need to make sure that it's well ventilated. And that happens, that's not just in a truck, that's anywhere. And then the reality, this applies for any refrigerant, but it is very important for the A2Ls. The last bullet on screen notes that you have to have about 4.2 pounds of refrigerant for a typical cargo van to get to a point where it's thoroughly mixed and would be at a point where there might be ignition. There's also regulations that are important as it comes to storing the refrigerant vessels, whether it is a cylinder or units. There's certain restrictions that the United States Department of Transportation has. And again, as you're applying these in Canada, there's also regulations there that are very similar in nature. A lot of basic rules that we're using today. And if you recall, a lot of contractors will have acetylene tanks and other highly flammable fluids around. And so the same care that you use with those should be utilized for R32. One of the things to note coming relatively soon is in the past, I'm one of these old guys that have been around for a while, and I'm used to seeing different colors of cylinders. HI guideline N is changing the requirements, at least the specifications for the guideline, in that rather than using a color specific to a refrigerant, that all refrigerant tanks will be gray. And if it's flammable, it will have a red top. So you may see some in the field that might have a R32 light blue color, and then you might have others that would be gray with a red top, and then also those have to be appropriately marked. So though you'll see those coming in refrigerant cylinders. Real quickly, we'll run through some of the tools that you might need as you're servicing these products. Also from HI guideline, there will be, the proposal is that for the equipment that the same fittings will be used on the equipment, for example, R32, as you're using today with 410A. So most products today use a 1/4 inch SAE flare, Schrader fitting for accessing the refrigerant system. That won't change on the unit. However, the refrigerant tanks will change from a right-hand thread to a left-hand thread. So as you're getting out the cylinders, that will help you verify that you're not putting the wrong refrigerant in the system. As you go to using gauge sets, the same gauge sets can be utilized for 32 and 410A. If you're using the older analog type device that's shown on the screen, then you have to note that there will be a difference in the saturation temperatures for a given pressure. So you have to do that calculation manually, but if you're using digital gauges, those should automatically correct to the right saturation temperature based upon correct selection of the refrigerant. But the fittings on the gauge sets will be the same. The recovery tanks you need, recovery units you need, recovery units need to be approved for A2L. So you may need to get a different recovery machine than you have today. Depends upon the design of it. Some products today, some recovery machines today are good for a variety of refrigerants. So make sure you check and see what you have. It's similar on vacuum pumps. Some older vacuum pumps may not be certified for use with flammable refrigerants. So you need to make sure that any pumps you have are appropriate for use with an A2L. When it goes to electronic leak detectors, any electronic detector that is used for 410A can also be used for R32. So that's one you don't have to change. And again, noting that R410A is 50% R32 already anyway. Other tools that you might need is Other tools that you might want to use are those that check the area in general for flammable refrigerants. You may want to have one tool for a leak detection at the unit itself and another for just the area in general. You want to make sure you have, and this, it doesn't change from what you're at today. You may want to have a fire extinguisher nearby, especially as if you're doing any brazing. Obviously not necessary if you're using mechanical fittings like flare nuts. Again, you want to have a appropriate recovery cylinder for each type of refrigerant that you have, as well as in the event that there is you don't have a different different gauge, hose gauge set, you need an adapter for the tanks. And just a summary here, you see that very minor differences in the tools that you would need for R32 or 410A. And just run through the last few slides, and then we'll open up for questions to talk about some servicing considerations. One of the things is before you do any recovery, before you break into the system, you want to check around and make sure that there's not been any leaks. And if you do find a leak, then you make sure that you ventilate the area, circulate air, make sure that you don't have any ignition sources around. And just remember that, and this even applies for today, because it's possible that there could be liquid line solenoids or non-bleed TXVs and things of that nature that may trap refrigerant into certain portions of the system. So it's important to make sure that any valves are open, that you energize solenoids, et cetera, to make sure that before you break into the system, that you properly recover any and all refrigerant. It's a very good idea, as noted in the picture, to after you've done as much recovery as you can through these radiator ports, that you puncture a hole, and that you cut out parts that need to be replaced instead of brazing them out. And that even applies today, because there could be oil circulating through the system. And if there's some oil in the tubing area where you're cutting, then that oil can also light on fire. This is a chart of a summary from the safety standard 2-40, where it gives requirements for service. And the thing that I want to point out is that for these items noted, you see that for A2Ls, there's only a couple items that's recommended for additional items when you're servicing. So it is recommended, not mandatory, but optional per the 2-40, that you purge the system with dry nitrogen, and then you evacuate it again. So making sure that you're getting out any flammable mixtures. Again, optional, not mandatory. And we will close out. Last slide is just when you're executing repairs indoor, make sure you have sufficient airflow and mixing of air, that you're bringing in fresh air into the room if you're working inside, to avoid any buildup of refrigerant. And similar when you're working outside, as long as the wind's blowing, you should be okay. But you want to make sure that you're not in a pit somewhere where there might be a buildup. And then with any refrigeration system, you want to make sure that you don't get air inside the system. That is could be bad for the compressor and for other components to get moisture inside the system and or a flammable mixture inside the tubing. So with that, that is my last slide. And we will go back to HRI for questions.
Hi, Rusty. I was going to ask you actually if you could put up, I think on the very first slide you had your contact information. And I was wondering if you could, and if not, that's okay.
Yeah, actually, I did not.
Oh, that's okay. That's okay.
Have my name. I don't have Rusty.Tharp at goodmanmfg.com.
Okay. So if anybody wants to get in touch with Rusty directly, you can certainly do that. And if you did not get the email address, feel free to reach out to HRAI, and we can certainly forward that on to you. We'll open the floor up for questions if anyone has any. And all you'd have to do is go to the Q&A section and insert your question there, and I'll either read it out or you can actually ask it verbally if you'd like. Just let me know. Rusty, are there any sort of key things that people could take away from your presentation today? I know the last slide actually sort of covered that, but anything at sort of high level, just as we're waiting for some questions to come in.
Yeah, I think so. What I would like to emphasize is that I know my company wants to be a very good corporate steward, a good corporate citizen, and we do believe that products with these air conditioners and heat pumps with these refrigerants will be better for the environment. We think it'll be better for consumers, and we're very anxious to get these products into the hands of contractors and distributors and customers. So any demand that if the contractors ask the distributors for it, distributors will ask the manufacturers for it, and so we can help move things along that way. And again, I think one of the bigger takeaways that I would like everyone to understand is that there are a lot of similarities to the systems that we're using today. Obviously, there are differences, as noted, because the refrigerant itself is flammable, and we have to keep that into consideration. And we want to make sure that everyone applies these safely and appropriately. And I think going back maybe to that one slide on some of the bigger takeaways is that as you're applying these, as contractors are installing these systems, that one of the best things to do is just to make sure that they verify the minimum areas met and know what the refrigerant charge is. And typically most systems today, there is on the nameplate of the system, there is a factory charge that is listed, and units that have an A2L refrigerant will have a space intended for the installer to write down how much refrigerant they added. So for example, if the factory charge was 6 pounds and there was a fairly long line set, and the installer needed to add 2 pounds of refrigerant, so now the system as a whole has 8 pounds. As you're taking that into consideration, the minimum area needs to consider the 8 pounds, not just the 6 pounds of factory charge. And I think, so a lot of this, some of this is somewhat common sense. Reviewing labels and literature, it's always important for safety to make sure that you, whether it's a user or installer or service person, know what the requirements are, and you can do that by reviewing the literature and labels.
All right. Okay, sounds good. We don't have any questions, so I think what I might do is we'll call this presentation to its end. And I want to thank Rusty so much for participating today. We really do appreciate it. This presentation is recorded, so you could get it, listen to it again afterwards, and please feel free to share it with your colleagues. Rusty, you want to say just a few words of thank you?
Thank you for the opportunity, and I hope everyone
Absolutely.
has a great Thursday.
Okay, that's wonderful. Thank you so much, and have a great day, everyone.